the remainder theorem. Let's talk about the remainder theorem. Our objective, evaluate a polynomial using the remainder theorem. So what do we know that's going to be helpful to us? Well, let's remember that division algorithm. Dividend divided by divisor is equal to the quotient plus the remainder divided by the divisor. And we've worked with that in the previous, couple of videos anyways. Okay, so we've been doing this. Okay, now let's take this and let's multiply both sides by the divisor. Okay, assuming the divisor, of course, is not 0, which it can't be because it wouldn't work. So I'm going to multiply this side by the divisor and multiply this side by the divisor. Divisor. Okay, well, this obviously cancels that out, and on the left side we get the dividend. Okay, this multiplies divisor times quotient, and then this, of course, cancels out this piece. So we wind up with, on the left, the dividend by itself. On the right, we're going to multiply the divisor by the quotient. That's here. And then we're going to add simply the remainder, because the distribution of the divisor means that these two divisors cancel one another out. So we're going to be here once we do a little bit of algebra to that. We want to make use of this. Okay, slide it up a touch. Okay, the division algorithm in polynomial terms, if we're dividing by x minus c, it looks like this. The dividend, okay, that's our f of x, our polynomial, equals our divisor, x minus c, times our quotient, q of x, plus the remainder r. Okay, as a reminder, when you're dividing by a linear divisor, you have a remainder that is a constant. Okay, only when you're dividing by a linear divisor. Let's take a look at this and evaluate the above equation when x is equal to c. So we have this. I'm going to copy this down, in which this, let's get myself, this comes from this right here, but it's in kind of in polynomial terms with a linear divisor. So our dividend is equal to our divisor times our quotient plus our remainder. We came up with that right here. So what happens if we put in c for x? So what is f of c? I'm going to put in c here. I'm going to put in q of c here, plus the remainder. Well, guess what? C minus c is nothing. So f of c is equal to 0 times q of c plus the remainder. And of course, 0 times anything is 0. So f of c is our remainder. Okay, so what does that tell us? This is our remainder theorem. If the polynomial f of x is divided by x minus c, then the remainder is whatever it is, f of c. The remainder is equal to whatever value comes out when you put c in. It's what your remainder is. Okay, nice little theorem to know. Let's take a look at, as usual, let's take a look at an example, and then we'll double check ourselves. We will check ourselves with synthetic division. Let's make sure I'm in the right place here. I've got too many papers running around on my desk sometimes. Okay. Let's see here. I don't want that. Okay, so here we are. Given f of x is equal to a third degree polynomial, x cubed minus 4x squared plus 5x plus 3, let's use the remainder theorem to find what f of 2 is. Okay, well, the remainder theorem says just put it in there. What comes out is the remainder. Okay, so f of 2 is, and I use parentheses, 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. Okay, f of 2. Okay, well, I can put this into a calculator. 8 minus 16 plus 10 plus 3, and out comes 5. Okay, so that simply tells us by the remainder theorem, the remainder is 5. Okay, which is obviously is not 0, so we don't have a factor here, but the remainder is 5. Okay, that's all you have to remainder theorem. Let's check this using the synthetic division. Do we get a remainder of 5? And we'll practice our synthetic division in the process. T-H-E-T-I-C, synthetic division. Okay, well, here's 2. So this is kind of like x minus 2. So we'll put 2 over here and put it into a half box like I like to do. We'll pull the coefficients, 1, negative 4, 5, and 3. 1, negative 4, 5, and 3. And this, as we know, is row 1. Okay, we're going to go like this. This is going to be row 2. And this is going to be row 3. Okay. Now we have all the, let's see, we make sure we have all, we don't have any missing, it's already in standard form. So let's pull the 1 down to row 3. And then let's do our multiplication and our addition. 2 times 1 is 2. Let's add, we get negative 2. Let's multiply, 2 times negative 2 is negative 4. Let's add, we get 1. 2 times 1 is 2. Let's add, we get 5. And as we remember, once all the columns are filled, completed, the last number in row 3 is the remainder. Okay, well, that checks out. We used synthetic division for 2, and we came out with a remainder of 5 using synthetic division. But the remainder theorem said, no worries, just if you want the remainder of whatever it is when it's 2, just put it in there and out comes the remainder. Okay, so that's your remainder theorem. Fairly straightforward.